In this video, I'm going to show you how to create depth first search using in order in a binary search tree. In the previous video, I showed you how to do a depth first search in pre-order. Okay, and in case you didn't hear me from the previous lecture, I said that depth first search has three possible alternatives in which we can perform a depth first search. You got pre-order, in order, and post order. Now the cool thing about this is that we already have the pre-order done. That leaves us with two others. The only thing that we have to do to make the other two work is simply change one line of code in this function here. So I can just pretty much copy this here, and I'm going to go ahead and paste right here and call the depth first search in order. And all it takes is changing the position of this line right here. The position in which we push the current node's value. Okay, so in the pre-order, it was over here, right at the very beginning before we even started the traversal. All right, but now that this is in order, all we have to do, as I said, it involves this line right here. I'm gonna delete this from this position here and place it right dab in the middle right here between these two others. Let me redo that here. All right, there you go. And that's it. This right here, switching the position, changes the order completely and gives us the in order, the depth first search in order. And the in order would give us, as it sounds, it's in order, depth first search in order, meaning that we're gonna get an array of these numbers here in order, in their order from lowest to highest value. Therefore, we will get an array of 3, 7, 9, 10, and 12, right? So it's gonna go down here, and then here, and then here, and then here, and then here, in order. So that's all it takes is just replacing the line from one position to another. Now I want to in this video, but as a matter of fact, let me go ahead and output this to show you that we're gonna get the result that we want. So I'm gonna do console log tree.depth first search in order, and then here I got my console. And we should see this in the console here. It's going to match this. So I'm going to run this snippet of code and look at what we get here. It's a match. 3, 7, 9, 10, 12 in order. But as I said before, we are using traversal here. Oh, I'm sorry. Excuse me. Recursion. And recursion is tricky. It is tricky. I have to be honest. And my experience to this day, I mean, currently right now, I'm still getting the hang of it, but I'm much better than before. But if you're starting off, I mean, it's going to be confusing. So one of the things that helped me, and which I'm going to go through right now, is go through the call stack. So what I'm going to do here is, and we have a small data set here, so we can go through this. We can go through his call stack without a problem. So I'm going to set up a breakpoint. Oh, set up this breakpoint. Why is this going like this? All right. It's not what I wanted. Oh, how do I do this here? All right. All right. So I want to set up this breakpoint right over here. Why is it doing that? It's like it doesn't want me to set a breakpoint where I want it. All right, let me remove you again. Come on, help me out here. All right, so let me, all right, so I think this is what I'm gonna do here. I'm gonna refresh this page here. Maybe that'll do the trick. Go back here and then set my breakpoint right at the very beginning of this function here. Perfect. There we go. So now I have my breakpoint there. All right. And now what I'm going to do is I'm going to run this code, and we're going to get this side window open up here. And you're going to have, I'm going to have the cost stack here, and I have the scope. I'm going to close up this here. So I'm going to have this open as well with the variables locally. All right. So now we're going to go through this block of code. We're going to go through this function one step by step to see what's going on. All right. So we start off here. I'm going to step through code, and then it's going to make its way all the way down here to traverse. So we're going to call traverse, and notice here in the call stack, we don't have any traverse yet, but now that we arrive to this point, you're going to see it's going to be added to the call stack. So I'm going to step through code, and there's your first traverse in the call stack. So at that point, we get traverse called, and it has as its argument is going to have the node with the value of 10. So we are starting here at the root node, right? At the root node at the very top. So let's go ahead and step through this code. So we are currently here in the if statement. If current left, traverse current left. And you see, as I said, we're here. And so it's saying, do we have left child? And you're going to see that we do. So what's going to happen is we're going to traverse that, and it's going to add it to the call stack as well. Currently we have 1, and now we have 2. So now we did a traverse, but with a different input. This time with this right here, with this node, as you can see, this 7. All right, so we're going to continue again, and then now we arrive at the traverse again, and it's asking, do we have a left child again? Over here, does 7 have a left child? And it does. So you see, we're pretty much moving from the top all the way moving to the left, downwards to the left, right? So we're going to go through, and it also added another traverse. So now we have 3 traverses in the call stack. But at this point now, again, it's going to ask, because now we're here at this node here, and it's asking, does it have left child? Well, now it doesn't, right? So that means that this line is not even going to run. This traverse is not going to run anymore. It's going to run to the next line, which at this point means it's going to push the result, push this here into our result, which is right here. And you're going to see, once I step through, now we have over here, if you look to the side, result has the value 3. And then it's going to continue on, and it's going to ask, the code asks, does 3 have a right child? No, it doesn't. So at that point, this function ends, and then we're gonna pop off the traverse function and call stack relating to this one here, pertaining to this one. We're gonna pop it off the stack, and then meaning it's gonna have to backtrack. So we're gonna run through, and now you see it went from 3 to 2 traverses. So now we backtracked, meaning we're gonna go back to 7. And when we were at the traverse for 7, we left off over here. All right, so now at this point we're 7, and we're just going to push in 7 into the result here. And if you look at the result, we get 7. And we go to the next line. So does 7 have a right child? Yes, it does. So we're going to traverse that, and you're going to see that now we're going to have another traverse in the call stack from 2 to 3. If I step through, there you go. Now we get 3. So now we are currently at the node for 9. Here it says 9, meaning we are right here. So at this point, we go through a block of code, and we're going to push this value into the result. So you see here, currently the result is 379. And at that point, it doesn't have a right child. So it's going to end that traverse. And now we're going to pop off the traverse for this node here, meaning we're going to have to backtrack and go back, retrace our steps backwards, which we're going to end up here. So if I step through this code, there we are. We're currently at this node with value of 7, as I said here, and we have one less traverse here in the call stack. So at this point here, we're at 7, and we're going to have to pop off the traverse for this node here and backtrack to this node here. So if I step through, there you go. You see value 10, meaning we're here, and we have one traverse. So now at this point, when we're at this traverse here, we left off over here. So we're gonna push the value 10 into the result, and as you can see, now we have 3, 7, 9, 10, and then we move to the next line. Does 10 have a right child? Yes, it does. So we're gonna do a traverse. And traverse is going to be added to the call stack. So look, it has 1. We're going to go to 2, and there you go. You got 2, and we are currently at the node with value of 12, which is this here. So at that point, it asks, does this node with 12 have a left child? No, it doesn't. So we're just going to push this value 12 into the result, and there you go, 12. Now we got 12. And then it asks, does this node have a right child? No, it doesn't. So at that point, this traverse finishes. So we're gonna start popping up. We're gonna pop off the traverse method for this one right here off the call stack, and it's gonna backtrack to where to backtrack its to number 10. So we're gonna call this. Go step through code. Now we get one traverse left, and then at this point, this is gonna pop off the stack as well, and we have no more. And then the function returns the result, and that is it. And here is the final result. What we get is this right here, and that is it. And there's your result. All right, so I know maybe even with my explanation through here, it might have been confusing. All right, and believe me, even me hearing other tutorials myself when I was learning, it was difficult. But I tell you, it's gonna help you out. Just have a small data set like this and go step by step through the call stack and see what's going on, especially when we're talking about recursion. All right, set your breakpoint at the beginning of the function and just step through code. All right, so here you have your button to step one by one, and then as you're stepping through, you're gonna see the variables and the values that are in the variables and all these changes, and you're gonna see the call stack with the functions that are currently there and them being popped off. So that's my advice to you. Okay, and anyways, as I said before, that first search with in order, pre-order, and post-order, all it involves, the difference is this line of code and just changing the position of it. All right, but this is your depth first search in order.